Hello everyone, welcome to DTech. In this video, we're going to discuss about Agentic RAG and its implementation by using Local LLaMA 3.2 model and OpenAI GPT4o model. Before we're going into Agentic RAG, first we'll try to understand Retrieval-Augmented Generation, simply known as RAG, and what is the difference between traditional RAG and Agentic RAG. And also we'll explore two different use cases practically by doing hands-on. So first we'll try to understand what is Retrieval-Augmented Generation. As we know, LLM's knowledge is limited and it doesn't have any information about our personal data. For example, if you're working in any enterprise, the data belongs to that enterprise. It's not exposed to LLM, right? If you're actually asking any questions with respect to that particular enterprise related data, it will not be able to provide any answers for that because these models are not trained on that particular data set yet. And for example, consider you have lost 10 years of transaction history with you. And if you ask LLM about how much did I spend on groceries last month, it will not be able to answer that particular question because it didn't train on your transaction summary or transaction history data. If it is one or two files, we can actually upload those files into ChatGPT and then we can get insights about our data. But if you're talking about very big and huge amount of data, then we need to have a mechanism to implement. This is where exactly RAGs comes into the picture. What we can do, we can implement a RAG pipeline so that it can interact with our data and the LLMs will actually generalize the data for us and it will give the insights about our data. So far we understand about Retrieval-Augmented Generation, but we have to know how we can implement RAG here. It follows a three-step approach on a high level. First, we have our input data. It can be in any format like PDF, Word documents, PPTs or anything. And that needs to convert into Word embeddings. So how it will be converted into Word embeddings? We'll be using Local LLaMA models or OpenAI embeddings that will actually read the data and convert into Word embeddings for us. So Word embeddings are nothing but it is a numeric representation of our data. Once we actually created our Word embeddings here, it needs to store in a vector DB. So why vector DB? Why not other databases? Because vector DBs are specialized in storing and retrieving Word embeddings. Similarly, what we have OLAP and OLTP, those databases are used for that particular use cases. So that's the reason like we have vector DBs to store and retrieve Word embeddings data. The next step is when user is asking a query, that particular user query needs to convert into a Word embedding, and then LLM will actually check for that particular relevant Word embeddings from vector DB, and it will only get that relevant data from vector DB, and then it will actually convert into a natural language processing, and which can be easily understood by human, and it will send the response back to user. So this is a kind of a three-step approach. The first step is our input data. It can be in any format. The second step, converting those input data into Word embeddings and storing into vector DB. The third step is retrieving the relevant information. When user is asking a question, RAG retrieves only the relevant part of your data and provides a response to the user. So now I understand Retrieval-Augmented Generation and how Retrieval-Augmented Generation works. So the key difference between traditional RAG and Agentic RAG is the agents on top of RAG is Agentic RAG. So a lot of things why we use Agentic AI is a lot of things will happen autonomously. So we need not to provide each and every action over there. A lot of things agents will take care of us. For example, if you're actually working in a financial chatbot and you're actually asking about what is the breakdown of last month spending on groceries from my transaction history. So the traditional RAG will give the detailed breakdown of what is your spendings on groceries last month. And if you're asking about can you actually sum up each and every transaction and give me the grand total, the traditional RAG will not be able to perform that task autonomously. The agentic RAGs will actually come up with an autonomous tool calling. So what it will do basically, it will actually call a calculator tool and take each individual transaction and sum each individual transactions, and then it will actually come up with the grand total for that. So this is where exactly Agentic RAG, a lot of things will actually taken care by agents. So this is how Agentic RAG works. We can see pretty much it is similar to what RAG provides. In addition to that, it has agents on top of tools. These tools will be called automatically by the agents. So there are some other use cases like it can perform calculations and it can perform query databases to pull structured data for us, and it can execute workflows, and it can adapt to the changing context. Basically, if you're actually changing the context from which is not available in your knowledge base in your local data files, that needs to search in somewhere and then give that information back to you. So far we discussed about all the theory. Now it's time to implement our first use case. Our first use case is getting movie suggestions from IMDb data. For that we'll be using IMDb movie data. So let me open the file. So this is the IMDb movie dataset where we can see here around 1000 movies consist of different genre, description and IMDb ratings, director, actors and all of that information here. And what we will do here, we'll build a RAG pipeline. So this is the data file which is in my local, and we'll build a RAG pipeline and then we'll get movie suggestions by using LLM calls. And for this we will be using OpenHums, which is basically it's a open source mathematics model, and we will be using llama 3.2 model, and we will be using LansDB for storing and retrieving word embeddings. That is basically retrieving the relevant content from our knowledge base. So first we'll start with our project setup. For that, let's create a folder and import it. So I created a folder and I imported the folder. The first step is we'll create a Python virtual environment. So let's go to terminal. Just zooming in a little bit. That Python dash ham vnv create virtual environment. Time, let's create a requirement .txt. We'll import all the libraries that is required. First one will be using Phidata, so we'll be adding Phidata to it, and then we'll be using OpenAI, and then we'll be using LLaMA and LansDB. LansDB is our vector DB, so that's why we're using LansDB here. TV. So this is something like LansDB internally uses this one to search and retrieve word embeddings from this database. SQL Alchemy, this is something LansDB uses internally, so we have to add these libraries. And we have got python.environment to actually import OpenAI keys here, and we got pandas as well. Now the virtual environment got created, and we also created requirements.txt file. Let's activate this environment for us. vnv/scripts /activate. So now the environment is activated. We'll install all the necessary libraries for us. Okay, we run command -r requirements.txt. Now we have installed all the necessary libraries for us. So first we'll start with our creating first Python file. Name it as Agentic RAG IMDb dataset. So we'll import necessary libraries. First we'll start with from phi.agent. So we'll be adding an agent. So for that we'll be using Phidata library. Import agent. And from so we'll be implementing this use case by using LLaMA, and we'll be using OpenHums LLaMA embedders. So for that we'll be importing the phi.model. So we can see a lot of models here. We'll be using LLaMA model, so we'll stick with LLaMA and import LLaMA. And the third one is we will be importing from phi. So we will convert our documents into word embeddings. So for that reason we'll be importing the word embeddings library. So we'll be adding LLaMA and we'll be importing LLaMA embedder. So we have to actually install, if you don't have LLaMA, please install LLaMA in your computer. And once we install LLaMA, so we need to actually look for LLaMA here. We can see it is a recognized command, LLaMA and list. You can see here OpenHums. I actually downloaded the OpenHums model from LLaMA. If you want to download that, if you don't have that particular model, LLaMA run OpenHums so that it will download particular model, and then we can use this particular model to implement our word embeddings. And we will be using data which is in CSV file format. So we will be importing some necessary knowledge dot, and we will be using, you can see a lot of libraries like JSON, LangChain, llama index, PDF, S3, and all of that. From here we will be using CSV and import, it's a CSV knowledge base. So there are two things here. One is CSV knowledge base, another one is CSV URL. If it is in somewhere in internet, you can actually give CSV URL knowledge base here. So it's in my local, so I will be selecting CSV knowledge base here. And the next one is from phi.vector.db. So we'll be using LansDB here. So that's why I'll be importing LansDB. There are other things as well like ChromaDB, Cassandra, and all of that. We'll be using LansDB for that. So we'll be adding LansDB. phi.document.chunking. So chunking is nothing but, for suppose we have very big document, so we want to actually, we don't want to send entire data in a stretch. Basically we have to break it down into chunks, and we can actually send that in a chunks size instead of like sending everything in a single go. So chunking dot fixed chunking. There are other types of chunking as well, like we'll be importing fixed size chunking for this particular use case, but there are other types of chunking as well. You can see document chunking, agentic, recursive, semantic, and strategy chunking. So but for this particular use case we'll actually stick with fixed. Once we actually imported all the necessary libraries, so we will actually create a knowledge base which will actually get our input data, which is in our CSV format, and then we'll create an agent to actually retrieve that. For that, let me add a folder here, and I will add the IMDb movie dataset here. So we have around 1000 movie names, but I don't want to use the entire dataset because it's too big, and I'm also using 16 GB RAM. It will be too much for that 16 GB RAM, and we are running everything in local. So I would like to actually use the first 50 movie dataset, and rest I will actually remove it. The next step is we create a knowledge base. We'll provide our input data. For that, let's see, create a knowledge base, which is nothing but a RAG. Knowledge base equals to, and we will be importing CSV knowledge base, and we need to give a path here, right? So if you remember, like CSV knowledge base, it's in our local, but if you want to actually use any URL, you need to give URL here. Path equals to, we have inside data folder, and copy this guy. This is the path, and then we will set up our vector DB. So vector DB equals to, we'll be using LansDB. So we have LansDB here. Actually, I can correctly spell it. This is LansDB. And then LansDB need to give different augments here. What is the table name you want to create? Table name, basically, like, in a database, what is the table name with this particular data will be stored. So it's the IMDb movie dataset, so I will be using the same name as the dataset name. URI, which will be referenced to actually search that information, so it's basically saved into our local environment. That probably I'll just give a temporary path, and it's a LansDB, and it's IMDb. So this is the location we can give, and then there is another argument is search type. So basically, what is the kind of search that we have to perform here? We need to get word embeddings from LansDB, right? For that, let's add search type here. So we need to import this search type from LansDB, and search type dot, we can see different search types here. We can actually search for keyword, vector. Here we'll be using vector so that we can actually retrieve that. And finally, we need to mention one more argument, which is embedder. Embedder will be using OLLaMA embedder. Internally it will call OpenHums, right? You can see here, this is, yeah, you can see here it is model is OpenHums. If you didn't install this particular model, it will actually throw that exception. So that's why we actually install OpenHums in our LLaMA, and then we actually here setting up the LLaMA embedder here. Chunking strategy. So we'll be using fixed size chunking here. So fixed size chunking, and then we want to load fixed size chunking with the chunk size equals to 1024. You can use any other strategies as well. And then overlap equals to 10. Basically, when it is actually chunking, for suppose we have this IMDb dataset. When we're actually chunking with 1024, it will store till this information, right? When we're actually giving some overlap, basically the next chunk will start from here to the next 1024 chunk size. So this is where, like, you need to actually give that particular context about, it's not like a separate thing, it is actually maintaining that context. So now we set up our knowledge base. Our knowledge base consists of path, and then we are actually setting up the vector DB and table name. URI search type is vector search type, and then we are using LLaMA embedder here. Now we set up our knowledge base. The second thing that we have to set up here is an agent, right? In order to set up an agent underscore RAG underscore IMDb. Here we'll be using model as LLaMA, and the model will be using LLaMA 3.2. So OpenHums is the model for word embeddings. So once we have the word embeddings received from the LansDB, it needs to be converted into human readable format. For that, we'll be using LLaMA 3.2. So first argument is we gave our model as LLaMA 3.2, and we can actually give our knowledge, right? So this is where knowledge base equals to, basically, like, we are actually giving the LLM. If the user is asking about a particular question, first refer to this particular knowledge base. If that particular question can be answered by using this knowledge base, respond the user with that particular answer. If it is not available, then we can actually autonomously call some other search engines to get that information. So here we created a knowledge base, and what's the knowledge base that we gave? Yep, here is knowledge base equals to knowledge base. This is for debugging purpose. It needs to like show tool calls equals to true. This will actually show us what are the different tools it is calling internally, and then markdown equals to true, so that we can see that in markdown format. If you want, we can actually give some sort of instructions like to agent to perform. Please display data in tabular format. Once it is done, what we did really, like, we first created a knowledge base and we gave that knowledge base to our agent. Now we are actually invoking the agent to perform the task for us. Like IMDb dot print response. We'll ask about can you suggest top 2 science fiction movies with high ratings, and we will actually enable the stream equals to true, so we can actually see what's happening behind the scenes. That's pretty much. There is some exception it was showing. Sorry, I missed the comma here. Now we will run the Python agentic underscore RAG underscore IMDb.py. It took nearly 14 minutes to run this particular query, and basically like the first 10 to 11 minutes it's trying to read the data from IMDb movie dataset, and it is creating the word embeddings for us. It took nearly 11 to 12 minutes to create the word embeddings, and after that it took nearly 3 minutes to respond back with 2 top science fiction movies from provided data. You can see here this is Guardians of the Galaxy, which is having 8.1, Prometheus, which is 7.0. So these two coming from our data set. Once we actually created the knowledge base, every time this query almost it took 15 minutes, but every time we needed to actually create word embeddings and then store that into the LansDB, right? For that, you just comment this one because it doesn't require every time. So once we load it into the LansDB, every time we have to retrieve it, we need to actually create word embeddings for every query so that we can actually save at least 10 to 11 minutes of time. So basically I rerun the program again with commenting this line. So this time it's not actually going to create word embeddings, it's actually referring the word embeddings, and then it is searching that particular query, and then it is giving these two results here. First one is Guardians of Galaxy and the second one is Prometheus. But I'm actually not convinced with the results because we can see from our dataset, first one is Guardians of the Galaxy, but second one is Interstellar. So, but from ratings point of view, Interstellar is the first one, and the second one is Guardians of the Galaxy. So it actually picked up something else. So it's not actually top two movies. It's maybe second best, this one. But Prometheus is definitely not the best movie. This is due to because we are using Llama 3.2 local models and we are using OLLaMA embeddings, but we'll try to see the same thing with OpenAI embeddings and OpenAI GPT4o model to see like how the accuracy of the model. We'll actually take the same code and we'll try to rerun with the OpenAI models. So now we will add some additional functionality to it. First, what we will do agent underscore RAG IMDb. We will add, I would like to fetch recent news in USA. So what is recent news in the USA? And I would like to also fetch basically I will be using one CNN news. I would like to summarize that CNN news. So for that I will be using this news article. This is the news article I'd like to summarize. And then we would like to get recent news in the USA. And the first question, can you suggest top 2 science fiction movies with high ratings from our knowledge base, basically, right? So from knowledge base. So for these two things, we need to actually enable some tools to do it. The first thing that we're going to use here is DuckDuckGo, and the second one is we'll be using newspaper 4K. For that, we need to add some additional libraries to our requirements.txt, which is going to be DuckDuckGo search and newspaper 4K and lxml underscore html underscore clean, which is a dependency library for newspaper 4K. For that, let's run pip install requirements.txt here. And once we actually install all the necessary libraries, we will be using phi.tools. And first one is our DuckDuckGo to actually search to get the recent news. Import DuckDuckGo. And the second one we will be using from phi.tools. We'll be using newspaper 4K to actually summarize the newspaper article for us. Import newspaper 4K. Once it is done, we will add these tools to our agent. Agent tools equals to, first one is DuckDuckGo and the second one is newspaper 4K. So what will happen, agents will actually autonomously call the particular tool. So here it will call the knowledge base, and in the second question it will actually call DuckDuckGo tool, and the third one it will actually call the newspaper 4K. So let's see how it will run. We need to give comma here. Now it's generated the response for us. We can see for the first question, it actually referred our search knowledge base, and it is actually getting the same two movies, Guardians of the Galaxy and Prometheus. And for the second question, what is recent news, it is actually using DuckDuckGo, really good, and it is actually getting 5 results here. This is the recent news about USA. For the third one, this is, can you summarize the article? It is using read article. This is actually coming from newspaper 4K. We can see here newspaper 4K. This is the augment read article here. So it is basically using news article for that. So, and actually it is summarized school shootings in the US and fast facts. This is really good. Like, we have actually provided all the tools, but it is actually Phidata and LLMs taking the call to which tool to call for that particular task. So except this movie suggestions, the rest of the things is working as expected. For this movie suggestions, what we will do, instead of using Llama 3.2 or OLLaMA embeddings, we will try to use OpenAI embeddings, and we'll also use OpenAI GPT4o model to see whether these particular suggestions are coming correctly or not. So we'll be using same code with OpenAI. So just copy the same code here, and we'll just rename it to IMDb instead of copy. Just keep it as underscore OpenAI. I will be making some adjustments. So we'll be creating .environment file, and we will be keeping our OpenAI API key here. I copied my OpenAI API key. Now we'll make some changes to the code. So here, instead of OLLaMA, we'll be using OpenAI, and we'll be using OpenAI chat. And instead of embedded.OLLaMA, we'll be using OpenAI, and we'll be using OpenAI embedded here, and rest is same, and we have the same path. And then we'll be using table name. We'll just give a little bit as maybe OpenAI, and URI we just give it here as well, OpenAI. Instead of OLLaMA embedded, we'll be using OpenAI embedded here. Okay, so by default it will be using text embedding 3 small OpenAI embedder. If you want to change it, you can actually change it to other models as well. So I'm good with that small embedder. And then after that, we'll be changing here, instead of OLLaMA, we'll be using OpenAI chat, and ID equals to GPT4o T-4o, and rest all pretty much same, and we're not changing any prompts here. Let's see how it will actually generate the response. So I forgot to import one more thing, which is .environment from .env import load.env, and we'll need to call load underscore .environment. And we need to actually uncomment this code as well, so that it needs to load into it needs to create a new embeddings, and it needs to store into the LansDB. So have uncommented this code as well. Now we'll see. It's creating new embeddings by using OpenAI embedder. Now the output is generated, and now we can see it is generated correctly. The first one is Interstellar, and second one is Guardians of the Galaxy, which is correct, because based on our CSV, this is what Interstellar is the first one, and the second one is Guardians of the Galaxy. So now it's maybe due to the Llama 3.2 issue. And after that, we can see here it actually picked up DuckDuckGo News, which is picked up the right tool here. And the third one, read article, which is again, it is using newspaper 4K. So it called the right tools for the particular task. For our second use case, we will be using our transaction data to actually analyze the transaction data and give some sort of insights for us. So it's basically like we'll ask question about how much did you spend on entertainment in January and February. So for that, it's a very simple use case. So we'll be creating a new Python file. We'll name it as Agentic _RAG transaction history .python file, and we actually import the necessary libraries that we actually used earlier. So this is the necessary libraries for OpenAI model, and we'll load the environment. Basically, you can copy paste everything here. So we actually imported the same libraries that we used, and load.environment, because we're going to use OpenAI GPT4o model for this. And then instead of IMDb movie data CSV, I actually added one transaction data which is created by using ChatGPT. So we can see here, this is the date, transaction ID, description about the transaction, and how much amount did we spend on, and then what is the category for that. Okay, so it's a very simple CSV file. Let's copy this one, and we will give this dataset name as this one, and we will change this one to, we'll keep the table name as dataset name, and instead of IMDb, yeah, we can use something called transaction history, and this is pretty much same. And then we will be using GPT4o, and we'll use the same tools as well, just to check it is calling the right tools or not. Anyway, we check that one, just keeping it as is. And this one, the first one which we need to ask is, can you provide how much user spend on entertainment in January? Please include grand total at the end. From knowledge base, please. We'll run this one and see. I think there's no issues with that. Let's run this one. Now it's creating new word embeddings and then storing into LansDB. And then it is searching for the knowledge base, which is right. You can see here Amazon Prime Video 200.99 and 444.32, and the grand total is 645.31. That's right. And for the second question, it is actually going to DuckDuckGo and getting the news for us. For the third use case, it is actually going to the read article and getting the summary of the particular article by using News 4K. Really good. I think just would like to double confirm that particular things are coming as expected or not. You can see here in the January month, Amazon Prime and Disney, and we can see the summary 200.99 and 444.32, which is correct, and it is getting the right response. This is pretty much about Agentic RAG implementation by using Phidata, Local LLaMA 3.2 model, and OpenAI GPT4o model. Thank you everyone. Thanks for joining. See you in the next.